Hey guys. Okay, so we are moving on to lesson 241. So this is the Friday lesson. So happy Friday. So what we've done so far, you guys, is just the basic. We've dropped the formal definition of the derivative, which has the limit. Okay, so just as a review, we know that f prime of x is the limit as x approaches h of f of x plus h minus f of x over h. That's the formal definition of the derivative. Okay, then what we did is we started learning about some rules that make our life a lot easier. Instead of using this limit definition, we have things called like the power rule that we already learned. And the power rule says, look, notation here, this d stands for the derivative, and then this is with respect to the variable x. So the derivative with respect to x of something that looks like x to the power of n. Okay, we simply take the exponent n, bring it down, multiply by x to one smaller exponent. Okay, and this is great when you have functions like y equals 3x to the 1/2, right? We could say, well, y prime is a half times 3 or 3/2, x to 1 smaller than 1/2, which is 1/2 minus 1 or negative 1/2. And then we would simplify and say it's 3 over 2 square root of x. Okay, so multiple choice on the AP exam, they will not leave these things with negative exponents. Okay. All right, so after we learn the power rule, that's great, except for when we have functions like maybe we have 2x cubed e to the x. Okay, and we have an issue here because the power rule, right, deals with simple functions that have an x, a variable, raised to some power. And you can see here, you guys, these are two separate functions being multiplied together. Okay, so we have like a cubic, right? And then we have an exponential function. And when we multiply them together, that's what our function is that we're trying to derive or come up with the derivative of. And we need more rules here. Okay, so what we're going to do today is we're going to learn a couple rules called the product rule and the quotient rule. And these are strategies, right? You memorize this on how you're going to take the derivative when you recognize that you have two separate functions. Again, a cubic and an exponential function. Okay, so when we take the derivative here, the product rule says, look, this capital F function is equal to this lowercase f times g. Don't worry about the same f's here. This could be a different letter h. It makes no difference. What you're going to memorize is that the derivative of this function is the original first function times the derivative of the second plus the second function times the derivative of the first. Some teachers, tell kids to memorize 1d2 plus 2d1. D stands for derivative. Okay, so 1d2 plus 2d1. Okay, so I'll do a couple examples here, and this will get easier the more we do. So we have this function y, and it's equal to this. So the first thing you guys have to do is make sure you understand why we're using the product rule. We're using the product rule because we have two separate functions being multiplied together, thus the product rule. So you would say y prime equals the first, which is 1 plus x squared. I did nothing to it. Times the derivative of e to the x. Remember, the derivative of e to the x is simply e to the x. Plus the second function, e to the x, times the derivative of your first function. Term by term, the derivative of 1 is 0, and x squared is just 2x using the power rule. And really, you're done. Okay, the calculus is over. You've done the product rule here. The question is, what do we do as far as simplification? Well, it just depends. I mean, if this was a multiple choice question, you would look at your answers and see what they did. In this case, it seems like both things have an e to the x. So maybe we factor out e to the x and we're left with x squared plus 2x plus 1. Okay, and then maybe on the AP exam, they go all the way and say, look, that's e to the x times x plus 1 quantity squared. Okay, and so for me on homework, what do I want? I want at least one step past your initial rule that you use. Okay, so you should at least get here. Okay, other ways this could show up is just giving you basic notation and then some particular values, and they want you to find y prime at 2. So if you want to find y prime at 2, you better find y prime first. Okay, well, if y is f times g, following my rule, y prime would be the first times the derivative of the second plus the second times the derivative of the first. And so then if we find y prime at 2, all that means is we're going to plug in our two values. We've got f of 2, g prime of 2 plus g of 2, f prime of 2. And all of these values have been given to you. So it's a simple substitution at this point. F of 2 is -1. G prime at 2 is -4. Plus G of 2 is 3. And F prime of 2 is -1. So we get a value of 4 minus 3 for an answer of 1. Okay, so in this case, the AP exam likes to give you functions that don't really have actual values like this, but then they give you particular values that they know you'll need to get your overall numerical answer. Okay? All right, so let's do another one. Same thing here. We've got a cubic, and then we've got an exponential. Hopefully at this point, visually, you can see that we clearly have two functions of x being multiplied together. Therefore, we need to use the product rule to solve it. Okay? All right, y prime would be the first, which is half of x squared minus 2x times the derivative of the second function. The derivative of 1 is 0. The derivative of e to the x is just e to the x, and the 2 just stays there, so it's 2e to the x. So first, derivative of second plus the second, which is 1 plus 2e to the x, times the derivative of the first. The derivative of the first, term by term, if I bring this 2 down, 2 times a half is 1, x to 1 smaller, which is just x. And then remember, this is a 1 you can't see, and 1 times -2 is -2. X to 1 smaller than 1 would be 0, right? And so it's just x minus 2. Okay. When things look like this, again, there's not really much you can do here. I would just distribute and try to see if there's any like terms. And so when you distribute, you get half times 2, which would just be 1. So x squared e to the x minus 2x e to the x. Plus, when you FOIL here, you get x minus 2 plus 2x e to the x minus 4 e to the x. Okay. And then you can see if there's anything in common. Looks like this 2x e to the x would cancel. This is just x's. That's just a number. That's squared. So there's nothing else that we can say. We could combine, so just rewrite it as x squared e to the x minus 4 e to the x plus x minus 2. Obviously, there's no correct or incorrect way to write out those terms. As long as your terms are all there with the correct sign, you get credit for that. Okay, so that's the product rule. And now we will move on to the quotient rule, which would hopefully make more sense now when we would apply it. You're going to apply the quotient rule when your problem starts as one function divided by another function. Okay, and so what we're going to do here is we're going to follow this rule. I definitely memorize this because, right, you have a subtraction here, which is not commutative. So you can't mess this order up, right? The product rule was a sum. And so if you did this out of order, you would still get the correct answer because addition is commutative, right? And so you want to make sure that you get this order correct. So you memorize low d high, which is the low function times the derivative of the high function minus high d low all over low squared. Okay, it's a mouthful. The more you do, it gets easier. But we've got it right here, and you can use this on homework. And assuming we're still distance learning, you can use it on tests. All right, so y prime. So low d high, low function, 2x minus 3. D high would be 2x, right? The derivative of x squared plus 1 is simply 2x. Low d high minus high, which is x squared plus 1. Don't forget your grouping symbols, right? Because you have minus signs. D low would be the derivative of the low function, which is just 2, all over low 2x minus 3 quantity squared. Okay. Almost always with these types of functions, you're going to distribute, combine, and see what happens here. So let's just keep doing that. And let's say that that's 4x squared minus 6x. This becomes 2x squared but minus. And then this becomes 2 but minus all over quantity 2x minus 3 squared. Okay. And then we can combine the x squareds and we get 2x squared minus 6x minus 2 all over 2x minus 3 squared. Looks like we can take a 2 out and we get 2x minus 3x minus 1 all over 2x minus 3 quantity squared. I'm not sure which one, if this was an AP exam, I think either of those are fair game. Since this didn't factor again, they might leave it as a trinomial here. Either way, it doesn't matter. So what do we need for the test? For the test, either it's going to be multiple choice and you pick the correct one, Or if it's a free response problem, this is not far enough. So applying the calculus definition of the quotient rule is good, but you need to simplify past that because that's going to be helpful later on when we apply derivatives to actual applications. Okay. All right. So find the derivative of y if y starts as this. Again, clearly a quotient function, e to the x over 3x plus 1. And so let's just jump in here. Y prime equals low. D high, remember the derivative e to the x is e to the x, minus high, which is e to the x, d low, which would just be 3, all over 3x plus 1 quantity squared. Okay. All right. Up here, I'm going to take a different path this time. It seems like I can factor out e to the x, and what's left is 3x plus 1, right? And then minus 3, all over 3x plus 1 quantity squared. For a final answer of e to the x times 3x minus 2 over 3x plus 1 quantity squared. Okay, so like I said, once we drop this limit definition, this becomes much more of a mathematical class in regards to here's a rule, go apply the rule. Okay, so take your time, make sure you're checking your simple derivatives that you're doing along the way, and you should be good. All right, so I like this last example because, depending on the function you're given, you're supposed to pick, right, what rule you want to use. In this case, right, we have a function that's in terms of 1 and x squared plus 1, and some of you might be thinking, well, that's not a function of x. And so what if I rewrote this as x squared plus x to the negative 1? It's a really good thought if you were having it. The problem is we don't have a rule yet, which is coming up, but we don't have a rule yet where we have a complicated function to a power, right? We have this simple power rule that says, look, if I just have the variable x raised to some power, I know that it's n times x to the n minus 1. But this is more complicated, right? That's a loaded function because it's not just a variable. And on top of that, you've got variables to powers. And so we will learn a rule on how to do this. It's called the chain rule, but we're not quite there yet. So let's stick with the quotient rule here on this one. So the quotient rule says low, x squared plus x, d high. Well, what's the derivative of 1? Hopefully you remember a derivative of a constant is 0. Low d high high d low, so minus 1 times the derivative of low, which is 2x plus 1, all over low squared. Okay. All right, so what do we got here? This all goes to 0. And so we end up with negative 2x minus 1 all over x squared plus x all squared. Okay. And that's it. There's nothing really to do there. You could square that out. That's not usually how they're going to have their answers in the multiple choice, so you're good to go. Okay, so at this point, we have 3 rules. We have the power rule. We now have the quotient rule and the product rule. Okay, and the rest of this chapter will just be adding on some more rules. All right, you guys, happy Friday. Enjoy it. Get everything turned in tonight by 11:59. Notes through Edpuzzle and 5 worksheets submitted to me through Schoology. Bye-bye.